Okay, in this video, we're talking about the continuous random variables. This is part 2 of the first section. So our only learning target for this is using the probability distribution of a continuous random variable to calculate the probability of an event. So a continuous random variable can take on any value in an interval on the number line. So before with discrete, we were looking at 1, 2, 3, 4, so on and so forth. But now we're talking about all those decimals in between. So how to find the probability of a continuous random variable. So the probability of any event involving a continuous random variable is the area under the density curve and directly above the values on the horizontal axis. So it's the area. So in this particular graph that we have here, it's the area of this box. So here we have a rectangle, and to find the area of a rectangle is base times height. So that's how you find the area. All right, so for instance, Selena works at a bookstore in the Denver International Airport. She takes the airport train from the main terminal to get to work each day. The airport just opened a new walkway that would allow Selena to get from the main terminal to the bookstore in 4 minutes. She wonders if it'll be faster to walk or take the train to work. So let y equals Selena's journey time to work in minutes by train on a randomly selected day. The probability distribution of y can be modeled by a uniform density curve on the interval from 2 to 5 minutes. Find the probability that it will be quicker for Selena to take the train than to walk that day. So we're at 2 to 5 minutes. It says that the new walkway would allow Selena to get from the main terminal to the bookstore in 4 minutes. So that's why we're looking at less than 4. So the shaded area, base times height, 2 times a third, because you have 2 minutes, and the height here is 1/3. Now, how do we know the height? This is where you need to remember that one of the rules for a density curve is that the total area is 1. But that also comes from probability has to equal up to 1. So when you look at the entire length of this density curve, because the density curve is this bold line here, the length of this is 3, because you go from 2 minutes to 5 minutes. So if the length of this rectangle is 3, what does the height have to be in order for the multiplication to equal a product of 1? Well, that would be 1/3. So that's how we know the height is 1/3. So from 2 to 4 minutes, that's 2 minutes. 2 times 1/3 gives us 2/3. So this shaded area is an area of 2/3. So that means the probability that y is less than 4, that her journey by train or whatnot on a randomly selected day is less than 4 minutes, is 2/3. So there's a 66.7% chance that it'll be quicker for Selena to take the train to work on a randomly selected day. Now, there are other types of continuous random variables that do not give us a uniform distribution, like Selena's journey to work, but yet a normal distribution. So here we have the heights of young women that can be modeled by a normal distribution with a mean of 64 inches and a standard deviation of 2.7 inches. Suppose we chose a young woman at random, let y be her height. Find the probability that y is between 68 and 70 inclusive. So this is actually something that you've already done back in, I believe it was chapter 2. So we can do this by hand, right? We can go in and we can do our standardized scores. So here we have the lower bound, 68 minus 64 divided by the standard deviation of 2.7, and then we have our upper bound, right? Then we go to the table, we look for 1.0 and 2.2, and we go over to the 0.4 and the 0.2. We take these values, which here they're given to us, and we do our subtraction, and that gives us the area in between. We can do that. We can also use your calculator, right? So in your calculator, you're doing menu, I believe that it's distributions, and you're looking at the normal CDF because it's accumulation of area. So the lower would be the 1.48, the upper is the 2.2, mean and standard deviation are 0 and 1, or you could actually change that, and your lower could be 68, your upper is 70, and we use the mean of 64 and a standard deviation of 2.7. So this top one, or the one that's typed here, that's using the standardized scores. Whereas what I just wrote, that's just using the information that was provided without standardizing them. They'll both give you the same value. So it's your choice if you want to do the extra algebra to do the standardized scores or just leave it as it is. One thing to remember is you cannot write normal CDF on your paper to get credit. What you can do is list out those values. Upper 70, lower 68, mean is this, standard deviation is that. Or you can even show how to find the standardized scores. Alright, so that means that the probability that a randomly selected young woman has a height between 68 and 70 inches is about 0.056.